Hi students, so today we will be solving this particular problem. Alright, so the problem goes as integration of sine of x minus x cos x divided by x into x plus sine x into dx. Alright, this is also a kind of manipulation based problem, that is just a very simple manipulation, alright, will help us solve the entire problem within seconds. But that manipulation is quintessential to be able to solve this problem in the shortest possible way. Okay. So what is the manipulation that we have to do here? It is very simple, and that is you have to add and subtract x. Alright. Now you might ask me that how is this going to help us? Well, you will be able to see it shortly. Alright. What I have essentially done here is I have kept the original problem of ours same, but I have basically taken this extra component into our problem, alright, so that it will help us solve the problem. Now x minus x is 0 only, right? So ultimately we have nothing but sin x minus x cos x divided by whatever is given in the denominator. The original problem hasn't been changed. Only this part has been added, which actually is 0. This part is entirely 0, but we have taken this part for us to be able to solve the problem easily. In the next step, what we are expected to do is to club these x's together in accordance. Like this x, we will club it with sin x. The plus part of x, we will club it with sin x, and the negative x, we will club it with this minus x cos x. So in case if we do that, what will happen? Let's see. I clubbed this 1x with this sin x, and this minus 1x will be clubbed with nothing but the cos x part. Okay, this part and this part will get clubbed together. So ultimately we will be having this same thing. Okay, now how is this going to help us? Let's first break the problem a bit further in order to be able to understand that. So first we will keep this as it is, and then we will take an x common from both of them, so that we will be left with a 1 here in place of x, and here we will be left with cos x divided by x into x plus sin x into dx. Alright, I hope you are well aware of how to take common. Alright, if I take x common from here, then inside the bracket I will be left with a 1 here, and there is a cos x here. Okay, and what about the signs? Definitely if I take a minus common here, then it will become a plus. Alright, then only in the original format we will be getting a minus. You cannot, as I told you earlier also, you cannot change the originality of whatever problem has been presented to you. So if it is written as minus x cos x, then no matter how much of manipulation you do, you have to come to a point where you can get back to this original part. Okay, you just can't do this like, okay, I'm taking a minus common and here I'll write minus 1 and here I'll write minus cos x. No, you cannot do that, because if you do that, then the original part will get changed. All right, the basic idea here is to keep manipulating the problem instead of keep manipulating the problem without changing the original problem that has been presented to you. All right, so and these things are essentially taught in your 7th 8th grade, I think, like how to do how to take common. So for example, you have a minus a here and a minus ab here, right? So how do you take common from here? If I take minus a as common, then I'll be left with a 1 here, right? Because I'm taking the entire minus a away. So what will I be left with? Simply a 1. And here, from here, if I take minus a common, what will I be left with? Nothing but b. Alright. Now, how will you realize that the common part that I have taken is correct? Like, how will you ensure that this thing is correct? Let's go back again. Multiply these two and you will see that you will be getting the original thing only. Alright, this is what I was trying to explain it to you here. These things are already done in your 6th, 7th and 8th grade. Still, I showed you in case you get confused. Alright, so now that we have reached here, what next? We will simply separate the two parts. How? First, we will be, alright, just simply separate it like you normally do in case of fraction, that you will just repeat in this particular case. Okay, here also just separate the part. Dx. All right, now simply you have to cancel whatever is common and then you will get the simplified version of the problem. So here, as you can see, that this part and this part is common, so we will be left with a 1 by x into dx. And here you can see x gets cancelled, so ultimately what we will be left with is nothing but 1 plus cos x in the numerator and x plus sin x in the denominator. All right, now what next? 1 by x into dx, right? How shall you integrate it? We have already done it before. All right, 1 by x integration is not a very difficult thing, but what is the catch here is how will you integrate this particular part? This also we have done before actually. What you have to do is you have to simply consider the denominator as t. When you consider your denominator as t, now there is one more thing, that it is not compulsory that you will be taking the variable as t only. You can consider a, b, z, y, whatever you can, but please don't consider x, alright, because x is already used. So consider any other alphabet in the the possible 25 alphabets you have. You can use any one of them except x. There are total 26 alphabets. Except x, you can use any other 25 alphabets that is presented to you. Doesn't, however, mean that I'm using t, so you also have to use t. You can use a, b, c, d, f, g, h, whatever you can. All right, I have been using t because I am more comfortable with it, and I have solved all the problems till date using t as the variable, t and y and all. Okay, depending upon what the problem had to say. So here, anyways, here we will be considering our denominator as t. All right, and if I do that, then what will I get after taking the derivative? We have done these kinds of problems before. So if I take the derivative of x, we get a 1. If I take the derivative of sin x, we get a cos x, and of course we will be getting a dx here, and we will be getting a dt. All right, now as you can see that when you replace the denominator by t, you get a dt in place of this entire part. All right, so ultimately you get 1 by t into dt, right? And here you have a 1 by x into dx. Do you recognize a common formula that we have used multiple times in solving different kinds of problems? Yes, definitely you will, I hope, be able to recognize that this 1 by x, the integration of 1 by x dx is nothing but log of mod x minus of this one will be log of mod t plus c. All right, now here essentially, as I already told you about a log formula, that log a minus log b is nothing but log of a by b. So simply you can write this as log of x by t. considering x to be a here and t to be b here, you can do this, plus c. Is the problem yet over? No, it is not over, because you have to replace this t by the function that was originally given, that is nothing but x plus sine x. Okay, so if you do that, you will be getting an x plus sine x in the denominator plus c. All right, so this was actually a very easy question, didn't require this much of explanation, but I have explained it taking into account the fact that all kinds of students will be able to understand it in case they have not been serious in any of their previous classes. No one should get perplexed with any method here, because it is very easy and straightforward. Even in case you don't know any of the easy stuffs, it won't really hamper your progress in this particular chapter. I am trying to ensure that every single concept should reach out to you as much as possible. Okay, and so if you really like my video, then please don't forget to like, share, subscribe, and hit the notification bell icon for more of such exciting content. Well, okay, then we will now proceed to our next problem.